Welcome back for another lesson from Hartlepool College of Further Education in GCSE Maths. This one is week 8 and is all about factorising quadratics. Before we get started, we'll attempt the revision grid. So on the next couple of slides will be a range of revision type questions that you are to attempt to answer. So when they appear, pause the video, and then when you press play, I'll talk you through the answers, see how you did. Pause the video. Right, okay, so let's see how we did. So if we're having a look at the first couple of questions, we're all about bin mass. Do the thing in brackets first. So 2 times minus 4 will get you minus 8, but we're multiplying that by a minus on the outside. So really what we've got is positive 8, so plus 8. And then we're dividing that by 2 cubed. Well, we think 2 cubed is the same as 2 times 2 times 2. That gets us 8 on its own. So really what it's saying is what is 8 divided by 8? And the answer is 1. For the next one, we do the index first. So 3 squared, remember that's just 3 times 3, so really 9. And then we've got an add and we've got a times. You do the times next. So 2 times 3 is 6. 9 add 6 is 15. Next up, convert to decimals. So 2/3 is decimals. And again, you might just know this one, but if we didn't, the method is the top number, 2, divided by the bottom number, which is 3. And 3 goes into 2 0 times. It's too big, doesn't fit. So we need some decimal points. Put some zeros at the ready. Now, we didn't use the 2, so I'll cross that out and carry it back. 3 goes into 20 6 times because your nearest multiple is 18, which means you've got 2 left over, so 2 carries back. 3 into 20 again goes same as before, exactly 6 times, with 2 left over, 2 carries back. 3 into 20 goes 6 times, with 2 carry back. So what you're left with is 0.6 recurring, or another way of notating that is 0.6 with a dot above the 6 to indicate that the 6 keeps repeating. The next one isn't in fact even a decimal, it's just another way of representing division. 4 divided by 2, or if you want to set it out the same way, 4 divided by 2, well 2 goes into 4 twice, so your answer is just 2. Next up, we've got 9 times 23. So in my head, I'm thinking, well, I know 10 times 23 would be 230. So if I take one of those 23s away, that gets me 9 times 23. So my answer is 207. The next one, 16 times 16. Again, loads of different ways to do this. The answer ends up being 256. If you're struggling to do that, think 10 times 16 is 160. 5 times 16 would be 80. 1 more 16 would be another 16. So you end up with 160 add 80 is 240. Add 16 is 256. Next up, percentages. And remember that on a non-calculator paper, we'd be expected to be able to work in increments of 5 or 10%. So usually a good place to start 10%. So I think 10% of 80 is 8, and then we want 5%. And remember, 5% is half of 10%, and half of 8 is 4. Add the 8 and the 4 together, that gets us £12. Same sort of process for 35%. So again, start with 10%, and 10% of 180 is 18, which means 30% must be 3 lots of 18, which is 54, and then we want 5%. Remember, 5% is half of 10%, which is 18, so half of 18 is 9. So really, we don't want the 10% anymore, we just want to add the 30 and the 35%, 54 at 9 is 63, so £63. Next up, number machines. Remember, BidMass does not apply to this, we follow the process. So start with the input of 15, divide by 3 gets you 5, 5 add on 3 gets you an output of 8. If you're given the output, you work backwards and do the inverse operation, that is, you do the opposite each time. So start with the 9, do the opposite, we're going to subtract the 3, gets me 6. And then we're going to do the opposite, we're going to multiply by the 3, 6 3s are 18. Next up it says, which two prime numbers make 5 squared? Well, easy way to sort that out. 5 squared is really 25. And then list your prime numbers. So we've got 2, 3, 5, 7, 11, 13, 17, 19, 23. The next one will be higher than 25, so that's as far as I need to go. Now remember, a prime number is anything that only has 2 factors, one in the number itself. Or another way of thinking about that is it has no number that will divide by it. So 2 is a prime number because it only divides by 1 and 2. 3 is a prime number because it only divides by 1 and 3. 4 is not a prime number because it divides by 1 and 4, but also divides by 2. Same with 5, only divides by 1 and 5, so it's prime. 6 isn't because it also divides by 2 and 3. Hopefully we get the idea. And which two of those numbers add up to make 25 or 5 squared? Well, 2 add 23 seems to be the obvious one there. Next up, multiplying by tens and hundreds. So £2.50 times 10 is £25. And £2.21 times 100 is £221. List the factors of 32. So remember, a factor is anything like a whole number of times. So 1 in the number itself will always be a factor. Now, if it's a prime number, it will only have those two things. If it's not a prime, there'll be other things. Now, 32 is an even number, so I know 2 goes into 32. How many times? It goes in 16. So 16 must be a factor. 3 isn't a factor because you think your 3 times table, your nearest multiple is going to be 30 and 33, so not 32, so not a factor. 4 goes in exactly 8 times, so 8 must also be a factor. 5 doesn't go, 6 doesn't go, 7 doesn't go, and then you're back to 8, so that's all your factors covered. Next up, 2 cubed, we covered this in the first question. Remember, that means 2 times 2 times 2. 2 twos are 4, times 2 again is 8. And the square root of 81. So which number multiplies by itself to give you 81? That's 9. So 9, square number. And remember, the examiner wants you to be able to remember at least your first 10 square numbers and the first 5 cube numbers. We need to work on those. Next up, we have the algebra grid. So again, pause the video, attempt the questions, and then when you press play, I'll talk you through the answers. Okay, so the first one's all just about simplifying. The 4b and the minus 3b can combine. So 4b take away 3b is b on its own. We're left with just 2a, so we have 2a plus b. Again, if you've got b plus 2a, that's fine, but remember, usually you list your terms alphabetically, although in fairness, we didn't in the question. Next up, 12t add 3t, so we're doing this one and that one, a total of 15t. Can't do anything with a minus 4v, so we just list that separately. So our answer is 15t minus 4v. Next up, some equations. And again, remember, there's loads of different ways to do this. The way I tend to talk through it in class is think of a number. So we don't know where it is, but it's x. We're going to multiply that by the 2. We're going to add on the 8, and that gets us 18. So if I work backwards, that start with the 18, subtract the 8, leaves me with 10, divide by the 2, leaves me with 5. So the first one, x must equal 5. We do a similar process for the next one. Start with the 47, do the opposite, take off the 7, leaves me with 40. 40 divide by the 5 gets me 8, so x equals 8. Next up, some simplifiers. So we have 4 times x squared, because x times x is x squared. 4 times x squared is 4x squared. Next up, 12 divided by 2 is 6. 6 times d is 6d. Next question. Think of a number and add 12. The answer is 6. What number did I think of? Okay, so we've got a number. We don't know where it is. We're going to add 12 to it. Now, answer is 6. Now it looks a bit like an equation, so work it backwards. Start with the 6. Do the opposite. Take off the 12. Leaves me with minus 6. The number I was thinking of was minus 6. Simplify the following. Simplifies down to b squared times v squared. Now remember, when dealing with algebraic terms, you don't need to include the multiplication symbol between them. So b squared is the same as saying b squared times v squared. Next up, remember your BIDMAS. We need to do 2b divided by b. 2b divided by b is 2, and then we've got b plus 2. So b plus 2. Next up, some more solves. So something divided by 3 gets me 27. Another way of thinking about that is 27 times by 3 gets me the missing number, and that's 81. So for that one, x equals 81. And the next one is just another way of representing division. So something divided by 2 equals 4. Working backwards, that's 4 times 2 equals 8. So m must equal 8. Simplify the following. So if I have 3x squared and I add another 3x squared, I have a total of 6x squared. Don't be confused in adding powers. You only add powers when you're multiplying terms together. You subtract if you are dividing terms, like in the next one. Remember, x on its own is really x to the power 1. So we'd say, well, 6 times 3 is 6 divided by 3 is 2. X divided by x, subtract the powers, leaves you x to the power 0, which is 1. 2 times 1 is 2. Answer is 2. Or effectively, think of it as the x's are just cancelling each other out. Next up, 2y equals 8, or y equals 4. Just divide both sides by 2. And the next one, 5y equals 20, or working backwards, that's 20 divided by 5 is 4. Y is again 4. Now, the next one, I always try to include a question along this sort of lines because it usually comes up on our spec for the exam, and it's quite useful to be able to work out. So it reads, I had some sweets, I gave 1/3 away, I have 10 left. How many did I start with? Okay, so if we think about that, we've got a part of sweets, we cut that into thirds, so each part is equal, and I give this portion away here. Now I've got 10 left between this part, let me put it as a different colour, and this part. So if there's 10 between those two parts, that must mean each part is worth 5, which means I gave 5 away, which means I started with 15 sweets. There we go. So that's the algebra stuff. Right, on to the main lesson itself. So this is quadratics. Now don't let the name put you off. It's not nearly as complicated as it first sounds, and certainly not as complicated as it initially looks. Try to bear with it. I'll explain it as best I can. Okay, so this is what a quadratic looks like. Usually has a term in x squared, a term in just x, and it usually also has a constant as well. And we have some steps to try to factorize these. So step 1, we list the factor pairs of the last term. So for clarity, that is the factor pairs of the constant, the 6. Okay, so let's list those out. So we have 1 and 6, and we also have 2 and 3. Now I'm keeping these deliberately in pairs, not just listing all the factors, I'm listing them in pairs. Step 2, identify which pair of factors combine to give the number of the middle term. So we want a combination of factor pairs that will effectively get me that middle term, or the 5. Don't worry about the x for now, just concentrate on the number. And the way to do that is we'll compare our pairs of factors. So 1 and 6, well, they're both positive numbers, they can't get me a 5. 2 and 3, well, 2 add 3 adds to give me 5. So the combination of factors we want is 2 and 3. And step 3, we're going to arrange the pair of factors into brackets. Now what I mean by this is, and we saw this when we expanded these kind of brackets the other week, so there's my brackets. I always want an x in the front of each, and then I'm going to just put the terms in. So if we think up here we had a +2 and a +3, so in the brackets I need to put +2 and a +3. Now if we remember from the other week when we were expanding double brackets like this, if we multiply those terms out, so multiply the first two terms together, so that's x times x gets me x squared, and then we'll multiply the outer two terms, so x times +3 gets me 3x, then we'll do the inner two terms, so 2 times x gets me 2x, and then we do the last two terms, so 2 times the 3, and that gets us 6. If we combine the middle two terms, the 3x and 2x, what that gives us is x squared plus 5x plus 6, which is exactly what we started with. Effectively, think of factorising as the inverse operation to expanding the double brackets that we did the other week. Right, next example. So we have x squared plus 7x plus 10. And again, think of this as we need to break it down into steps. Step 1 is list the factor pairs of the last term. So we need to list the factors of 10. Okay, so if I think of that, that's 1 and 10, because 1 times 10 is 10. And we've also got 2 and 5, because 2 times 5. 3 is not a factor, 4 is not a factor, and then we're back to 5. So there's all my factor pairs. Step 2, identify which pair of factors combine to give the number of the middle term. So the number that we're looking for is 7. Can't make 7 out of the 1 and 10, but 2 add 5 gets me 7. So the factor pair I'm looking for is 2 and 5. Just make a quick note of that. 2 and 5. And again, both positive numbers there. Step 3, arrange the pair of factors in the brackets. So we'll do that same as we did before. So pair of brackets, I want x at the front of each, and then I want my factor pair. So +2 and +5. And again, we could go through the process of expanding that as a check to make sure we've got it right, but in this case, it is. Right, folks, so on the board, we've got 4 questions there. Pause the video when ready, attempt the questions, and when you press play, I'll talk us through the answers. Okay, so let's talk through them. So remember the steps. First one, we want to list our factor pairs of 4. So we've got 1 and 4, and we've got 2 and 2 in pairs. So which pair of factors gets us 5? Well, that's the 1 and the 4. So what we want there is x in front of each bracket, and we should have a +1 and a +4 in the other. Now, if you've gone to the way around, said x plus 4 in one bracket, x plus 1 in the other, that's still fine, that works fine. No problems with that. For the next one, we've got x squared plus 9x plus 14 equals 0. Don't worry too much about what equals 0 bit is. I'll explain there in a sec. So again, step 1, think of all your factor pairs of 14. So we've got 1 and 14, and we've got 2 and 7. Any of those make a 9? Yeah, the 2 and the 7. So our answer for that one is x plus 2 and x plus 7. Next one, think of all your factor pairs of 30. Quite a few of these. We've got 1 and 30. We've got 2 and 15. We've got 3 and 10. We've got 5 and 6. And then we're back to 6. So that's all the factor pairs. Any of those factor pairs add up to give me an 11? Yeah, the 5 and the 6. So for this one, we want x plus 5. And we want x plus 6. And then lastly, we've got x squared plus 12x plus 36 equals 0. So again, step 1, identify all the factor pairs of 36, quite a few of these as well. So we've got 1 and 36, we've got 2 and 18, we've got 3 and 12, we've got 4 and 9, 5 doesn't go, but 6 goes. Now 6 is a square number, so we just list that as 6 and 6. And then we want which pair of factors adds to get me 12, 6 and 6. So for that one, it's x plus 6 and x plus 6 again. And those are our answers. Now, make a note of those, correct anything that you got wrong. Just going to quickly get rid of all of these. I want to explain something else. Yeah, that's much easier to write than it is to take stuff off. Right, so that's what we should have had in neat. Now, it does say equals 0. I didn't explain that in the talk, so we don't need to worry too much about that just for now. But just in case you did wonder, there are solutions that we need to be able to know, but that's going to be later on in the course. We'll do sketching the quadratic graphs, and then you'll see it forms like a curve. And because it's a curve, it actually crosses the x-axis in 2 points. And because of that, we can say that it has 2 solutions, as in where it crosses the x-axis. Now, the solutions are fairly straightforward. If you have a positive number here, then your solution is x equals -1. But because it always crosses the x-axis in 2 places, there'll always be 2 solutions. So if you've got a +1 and a +4, the solutions are -1 and -4. If you had +5 and +6, then you've got solutions at -5 and -6, and so on. But again, don't worry too much about those. We'll come to them in a later lesson. Next up, and just as a quick reminder, this is a table of signs. If you multiply 2 positives together, it gets you a positive answer. If you multiply 2 negatives together, it gets you a positive answer. Any combination of positive and negative will result in a negative. Important to remember that for what's coming. Okay, the next one, factorising, we've got x squared minus 4x plus 3. Now that's important because what we discussed on the previous slide is that if you multiply 2 negative numbers together, you get a positive. So, same process, we're going to list the factor pairs of the last term. Now 3 is a prime number, so it's only got 2 factors, 1 and 3. And we need a pair of factors that will in some way combine to get me that -4. So we're going to identify which combination of factors will do it. Now if I said 1 and 3, well 1 and 3 multiplies to get the 3, so we know that they're both factors, but 1 and 3 gets me a +4. However, if I make these both negative numbers, so -1 and -3, if I multiply them together, I still get the +3 for the last term, which is what I want. -1 add -3, or -1 minus 3, gets you -4, which is again what we're looking for. So the factors that we need here is -1 and -3. And so for step 3, when we come to arrange these in brackets, I just want x's in the front of both brackets, and then I just follow that with a sign. So -1 and -3. Again, this one can be a little bit confusing if you're not comfortable with your table of signs. It's the same process as before. Pause the video, attempt the questions, and then I'll talk us through some answers in a sec. Right, okay, so again, let's have a look at these. So if we think for the first one, we've got a 4, so list our factors of 4, we've got 1 and 4, or we've got 2 and 2. Now this one here is a positive term, and this one here is a negative term, so again, these were all going to have to be negatives to get that minus 5. And the only combination there would be minus 1 and minus 4. For the next one, we've got an 8. So think your factors of 8, you've got 1 and 8, and you've got 2 and 4. And again, you get minus 6, they would all need to be negative. So minus 2 and minus 4 would be your factors that you're going to use. The next one, minus 10, your factors, you've got 1 and 10, and you've got 2 and 5. And because this bit's positive and that bit's negative, all your factors need to be negative. And then for the same on the last one, I think your factors are 15, you've got 1 and 15, and you've got 3 and 5. And again, because it's positive here and negative there, all got to be negative. So for the last one, it would be minus 3 and minus 5. So those are the answers that we should have got. And again, for the solutions, all we need to remember at this point in time is that if they're minus over here, the solutions will be positive. And again, as I say, it'll be more clear when we do sketching the graphs and we see what they physically look like to try to explain that better later on in the course. Okay, next up, this is the one that can be a little bit tricky. We have a negative last term, so x squared plus x minus 12. And just remember that x on its own is 1x. Useful thing to remember. Okay, so step 1, list the factor pairs for the last term. So we want all the factors of 12. So we've got 1 and 12, we've got 2 and 6, and we've got 3 and 4. So they're our factors. Now, we need to identify which pair of factors combine to give the number of the middle term. We've got to be really careful with the signs. Now, remember what we said. To have a negative number, we need one positive term and one negative term. So if we were to put them in brackets, we've got x in the front of each. We need one positive term and one negative term. And we need 1x. So have a look through your factor pairs. So can I make a positive 1 using a 1 and a 12? No, I can't. Can I make a positive 1 using a 2 and a 6? No, I can't. What about 3 and 4? Well, 3 add 4 is 7, so that's not good. If I had a minus 3 and a positive 4, so think you're on minus 3, you add 4, that gets you a positive 1, so that's what we're looking for. So we want the positive 4, so I'll put the 4 in there, and I want the minus 3. Put the minus 3 there. So that's how it works. Do another one, because this one's quite a tricky subject. So list the factor pairs for the last term, so we want all the factors of 15, so we've got 1 and 15, and we've got 3 and 5. And we need to make a positive 2. Okay, so I can't do it using the 1 and the 15. What about the 3 and the 5? Well, for this one I can. If I have positive 5 and I take away 3, that gets me positive 2. So they're the factor pairs I need. So arrange the pair of factors into brackets. Got x in the front of both. Minus 3 and positive 5. And again, just to be clear, if we'd written that the other way around and said x plus 5 in one and x minus 3 in the other, doesn't matter, that's fine. Still be correct. Okay, so some questions on the board. See how we got on. Sorry, pause the video, attempt the questions, and then I'll talk through some answers, see how we got on. Okay, so let's have a look at some answers. So for the first one, we had a minus 3 term. So the only factors there would be 1 and 3. And we needed a positive 2. So the only way we could do that is if we had a plus 3. So plus 3 and minus 1. For the next one, we had minus 8. So the correct factors would be 2 and 4. And to get positive 2, it needed to be plus 4, take away the 2. Or positive 2, positive 4 and a negative 2. For the next one, we had 9 and 3. And then for the plus 6, we had positive 9, negative 3. And then for the last one, we needed to make 21. So the correct factor pair to go for was 7 and minus 3. And that gets us the 4. And again, for the solutions, all we need to remember is if it's positive in the brackets, it's negative in the solution. and vice versa. So where we've got positive 3 here, we have negative 3 in the solution, and where we've got minus 1 in the bracket there, we have positive 1 in the solution. And again, more on that later on in the year. Right folks, so that was factorising quadratics. It is a tricky topic, could turn up on either paper, and is quite a useful one because it would cover a range of the sort of grade 4, grade 5 type questions that you might come across later on in the paper. And it's those marks that are really essential that we try to pick some up. Right folks, last revision grid. So on the next page will be a load of geometry measure questions, followed by some data and stats type questions. When they appear, press pause, attempt the questions, then I'll talk us through them. Pause the video now. Okay, let me talk us through some answers, see how we did. So for the first one, it just says calculate the area. Straightforward, however, notice that we have millimeters there, centimeters there. Can't multiply those two things together because they're different kinds of unit. We need to change them first. So let's scrub that and call it 2 centimeters. Now we can do it. So 2 times 8 is 16. Working in centimeters, talking about area, so it's 16 centimeters squared. Angles in a four-sided shape add up to 360 degrees. Sketch a trapezium. Now yours might not look like mine, but the identifying features of a trapezium is one set of parallel lines and two not parallel lines. So there's one kind of trapezium. Equally, yours might have been something like that, where this side and this side are parallel, still a trapezium. Next up, reflect the shape in the dotted line. Now that square there, or that vertex, I should say, is 2.5 squares to the mirror line, so it reflects 2.5 squares. This one is 1 square from the mirror line. This bottom point is again 2.5 to the mirror line, so it needs to reflect 2.5 out. And this one is 4 squares from the mirror line, so it needs to reflect 4 squares out. So our final shape should look a little bit like that. Next up, identify the exact shape shown here. That's the clue. It is a right-angled triangle. Now, if you'd said isosceles, that could be true, but can only be true if we know that this side and this side are the same length, and we don't know that. So we couldn't really get away with saying that it was. Next up, how many lines of symmetry does this shape have? Well, it's got one line of symmetry that runs through the middle that way. Next up, what is angle X? Well, think about what we know about parallel lines. There is a full lesson coming on parallel lines later on in the year, so if this sounds unfamiliar from school, then don't worry too much. Opposite angles always equal. So the angle that I've just drawn in there must be 120 because the opposite angle there is 120. Now, that 120 degrees here corresponds with this angle there. So that's called a corresponding angle, and corresponding angles always equal. So for that one, X equals 120 degrees. And again, full lesson coming on that later on in the year. Next up, it says enlarge the shape by factor 3. Well, it won't fit on the grid as is because we've got 1 square by 2 squares. But I could physically enlarge that shape by a factor 3 and still fit it on if I just rotated it a bit. So we need 3 squares by 6 squares. So I think 3 squares by 6 squares. There we go. So there's the enlarged shape. And then lastly, it says calculate the perimeter, and just with the area question, we can't use mixed units, so I'm going to call that 20 centimeters. So if that's 20 centimeters, we know that shape's a rectangle. This side's got to be 20 centimeters, and this side's got to be 8, because opposite sides of a rectangle are always the same. Remember, the perimeter is just adding all the sides together. So we've got 20 add 20 gets us 40. Add on the 2 8s gets us 56. This time we're just working in centimeters. So that is the geometry measure stuff for this week. Next up, some data and stats. Pause now, and then I will talk through the answers in a sec. Okay, so first question says find the range. So remember, the range is the biggest number, so 9. Take away the smallest number, which is 1. 9 take away 1 is 8. Describe how to find the mode. It is the most common value. So most common value. So all you need to do is have a quick look through your data and see which one's the most common. or if it's in some kind of table, find the value with the highest frequency. Next up, order these values and then find the median. So let's put them in order first. So we've got a 1, we've got a 2, 3, 4, and 5, 7, and 8. Okay, so we're looking for the middle value. So if we scratch off the N2, and then the next N2, and then the next N2, then whatever I'm left with must be the median, so the one in the middle. If, for whatever reason, you're left with 2 values in the middle, then you find the midpoint between those 2. Next up, we have a chart representing favourite colours. The first question on that reads, how many students are there in the colour survey? Well, let's have a check on that. So let's read them all off. So for the first one, we've got 4, and then we've got 7, and then we've got 6. So that would be all the boys. Next up, we got the girls. So that's 6 blue, 3 yellow, and 2 red. It says how many more boys than girls? Well, we need to tot them all up. So for the boys, we've got 4 add 6 add 7 is 17. So we've got 17 boys. And for girls, we've got 6 add 3 add 2, 9, 10, 11. How many more boys than girls? Well, that's 17, take away 11, 6. Provide a comment on the data given in the favourite colour chart. Now, this could be anything. It just needs to be something factual. So any valid fact that you've presented, you might give a particular example. You might say there were 6 boys, that chose red as the favourite colour. You could say red was the least popular colour across the genders. You could say blue and yellow tied with 10 apiece. Whatever you happen to say, so long as it was factual, that would be fine. Next up, if I roll a die, remember die is the singular for dice, 12 times, how many times would I expect to roll a 3 or a 4? So remember, expect is the key word. It's all about the expectation, not about what would actually happen. So if you think of it, if I was to say how many times would I expect to roll a 3, if I rolled it 6 times, you would expect to get 1 out of 6. If I wanted a 3 or a 4, and I rolled the dice 12 times, you would again expect to get, 2 out of 12, which simplifies to 1 out of 6. Draw a two-way table for the data in the colour chart. Difficult for me to do in the format that I'm doing it, but what you really need is sort of like the colours going this way, so blue, yellow, and red. We need a one for total, and then we want boys, girls, total going this way. Again, tricky to do using this, and then we want the lines going that way, and we just need to fill in the numbers. So, for example, boys and blue, there was 4 of those. For yellow, there was 7, and for red, there was 6, and for a total 17, and so on. So you just need to fill in the total. And then lastly, it says explain the term negative correlation. Negative correlation just means as one thing increases, another thing decreases. So imagine this is kind of a scatter chart. So if the data looks a little bit like this, that is, as this thing's increasing, as one thing increases, the other decreases. So your trend tends to follow a downward slope, going like that, as opposed to positive correlation, which would go the other way. So I think positive correlation will go that way. So I'll just label that as positive, and this one as negative. And again, we'll talk more about correlation later on in the year. Hopefully that's been of some use. Again, remember, if you need anything, if you get stuck with anything, if you need any help with any of the Canvas quizzes we put up online, feel free to drop your tutor a message on Teams or rewatch the appropriate video. Thanks very much. Cheers. Bye.